The real power of PredictK is released with the production analysis mode. All of the models and correlations for proppant performance are combined with the production simulator to provide an estimate of well production. PredictK is unique in that both fracture conductivity and producing fracture half length are continually calculated throughout the producing period. This training video will use the production analysis demo file posted along with this video. As always, double-clicking on one of the treatments will bring up the treatment options screen. All of the treatment options can now be changed. However, many of the inputs that were available in the dynamic analysis mode, such as bottom hole pressure and rate, will now become outputs that are calculated by the model and will change throughout the producing period of the well. Because this PredictK file involves a horizontal well, the treatment options seen here include the inputs specific to horizontal wells. A transverse or longitudinally fractured lateral can be simulated, and the total number of stages and fractures per stage can be input. Stage lateral length and frac spacing will be calculated based on the input lateral length whenever the number of stages and the number of fractures are changed. Well spacing will be used to limit the drainage area of the well. The other parameters have the same meaning as in other modes. Average proppant concentration, prop fracture length, and prop frac height can all be estimated or obtained from a frac model. Under job cost, the cost for each additional stage is input. Frac costs that are independent of the total number of stages should be included in the total well cost under model parameters. Proppant and fluid type can also be selected on the screen. While proppant and fluid properties will not be discussed in this video, this screen would be where those changes would be made for an individual treatment. The Well Information tab for production analysis mode is much more extensive because of the vast increase in model complexity needed to simulate production. These inputs are split into 5 different categories that will each be discussed individually. The first group contains all of the typical reservoir properties that PredictK needs. Many of these can be found from logs and petrophysical models used for the well being simulated. As always, default values are included that, depending on the input, can be used when better information is not available. The importance of finding better estimates will depend on the accuracy required for your particular situation and the goals of your project. Well properties are mostly used to calculate the friction during production. The production simulator needs a way to calculate bottom hole pressure and drawdown to determine production rates. If the surface pressure is input, the friction values allow for the calculation of this bottom hole pressure. Some of the inputs, such as TVD, temperature, and lateral length, are pretty self-explanatory, but an explanation of the remaining variables should help ensure that you can find appropriate values. PredictK uses the well radius to calculate an unstimulated well production rate. Therefore, this value will only be important if you are interested in that rate. The same is true for the horizontal skin and untreated contributing lateral fraction. The tubing diameter and pipe roughness should be input for the production string. Pipe roughness can typically be left at the default value, but the help menu gives estimates for different types of tubing if desired. Water rate is determined in the same way as it was in dynamic analysis. The rate either be input as a constant or set to a ratio of the produced fluid rate. The difference in this mode is that the produced fluid rate will now be changing. Actual water production rates can also be used if they are available. The remaining term, lateral vertical position, describes the well position in the target formation, with 0.5 representing a lateral placed in the center of the target. Model parameters are used to control how the model runs and the net present value calculations. The production simulator will run for the total production period input, performing calculations at a frequency determined by the time factor. The details of the time factor will not be discussed here, but the default value should work for most cases, and decreasing the time factor to a minimum value of 1 will use smaller time steps. A value less than 1 should never be used. You also have the ability to set a maximum production rate if the rate will be constrained in some way on the actual well. The last parameter under model properties, flow control, determines how the bottom hole flowing pressure will be calculated at each time step. The flowing pressure can be input as a bottom hole pressure, calculated from wellhead pressure, or determined based on a percent drawdown versus time. For bottom hole and surface pressure control, the constant option uses the same value for the controlling variable throughout the flow history, and the production option allows the user to input the controlling variable into a table based on production time. Fluid properties are used in both friction calculations and conversion from bottom hole to surface rates of oil and gas. Many are auto-calculated based on various inputs. But if better data is available, more accurate results can be obtained by using this data. Finally, a closure pressure gradient must be input so that the net stress on the proppant back can be calculated. At each time step, PredictK will recalculate net stress and find a new conductivity value along with all the other calculations that PredictK will perform. In production analysis mode, another tab is available containing a table for rates and pressure versus time. For this exercise, I will not be using this time. Actual production data can be included for comparison against the PredictK results, or a prescribed pressure and drawdown schedule can be input to be used by the production model. The last step is to click on the Perform Production Analysis button to run the model and populate the graphs. The results are very different in production mode. Closure stress, cumulative production, production rate, bottom hole pressure, width, and net present value are all plotted against time. Also, conductivity and permeability are reported based on a velocity term to show how rate affects the cleanup of the proppant pack. For a horizontal well, an additional graph details the rates for each individual fracture. This video has provided a basic overview of production analysis, but a full understanding of the model and how it can be used will be covered in other videos or from the training material available on the Proppant Consortium website. For help in using the production analysis mode in any particular application or any other PredictK questions, please contact me at steven.driley@corelab.com.